Okay, this is the second lab in Module 5 where we're going to demonstrate digitizing and how you can actually create data by just drawing right on your maps. There's a demonstration tutorial video that you can watch that actually shows you the process of digitizing, so this might be a little bit kind of out of order. But I want to talk about some of the issues that you might run into and things that you want to pay attention to when you're digitizing. Number one is that the detail is really important. If you have features that are supposed to connect to each other, you need to turn on a tool called snapping, which forces an exact fit between what you're digitizing, whether it's a point or a line or a polygon, forces them to fit together. If you're working at a scale, it might look right on the money, but as you zoom in and get it closer, you can see that the line didn't snap, didn't connect to the polygon, and if these two features were supposed to be coincident, we now have error that we're introducing. It's important to know that fixing these errors afterward is much more labor-intensive and time-consuming than just doing it correctly in the first place. So use the snapping tool, use those options, set your tolerance appropriately, and you will save yourself a lot of time in the long run. This is just an example from a different lab. These are traffic citation locations sitting on a road shapefile. And at this scale of 1 to 6,000, you can see that all the points look coincident with the lines. And if we were trying to merge these two shapefiles or connect these two data sets in any way, this is really critical, that these two feature classes are coincident in space. If we zoom in a little bit, it still looks pretty good. All these points look coincident with the line. But when we zoom way in, you can see that they actually sit very much off the line. And, you know, the computer can't rectify this. The computer can't say, oh, this probably is supposed to be on the line. These just simply don't exist in the same place in space. So there are ways you can fix this. You can run a snapping tool and force things like this to snap. When you're dealing with an intersection, sometimes you run into problems getting the point to snap to the correct line. So that's why doing it right the first place is really important. Okay, saving edits. I don't know if anyone, as you've been working along, if you've had ArcMap just unexpectedly crash or freeze up on you, but it's notorious for doing that. The important thing when you're digitizing, because this can get very labor intensive, you can spend a lot of time drawing features, tracing channels, adding points, whatever it is. You need to save your work as often as you can think to do it. This is a little bit of a review about how map projects are set up. Remember that an ArcMap project or an MXD file doesn't actually contain any spatial data. They just store the paths to the original source data. So you can see in this image here, this is drawing by location, and all of the data layers or maps that are being displayed in this map project are organized by what folder they're stored in on your computer or your flash drive. This is the only information that is contained in the map project. So when you're doing your digitizing, saving the map project isn't helping you at all. It's just saving any symbology changes or anything you've done to the data on the surface. But when you save the map document, you aren't saving your edits. You want to, when you start editing, use the editor toolbar to save your edits as often as possible. As you digitize along and you're saving your edits regularly, if ArcMap freezes up on you, you haven't lost anything. You haven't lost any work. If you've just been saving your map document as you work and are digitizing or editing, and ArcMap freezes up on you, you are losing all the work that you've done. You can see here the snapping. This is how you open the snapping toolbar too. Okay, so for this lab, you're using the same aerial images that you used in lab05A. So hopefully you got your georeferencing done correctly. You're going to be mapping land use change. So you're going to look at these two images, develop some categories for land use, and you're just going to subjectively decide what parts of this study area are being used for what kind of land use. So, like I said, you can pick any kind of categories you want. I recommend urban, agriculture, and undeveloped. You can add a riparian zone. I think it might be interesting to see the change in time. Here, they've allowed this to develop quite a bit. You might want to digitize paved surfaces. You know, the amount of roads has greatly increased. You could split urban into urban and residential. Know that this area, St. Helena, is known for its orchards. So these are all apple orchards, and that's what I mean by agriculture, but you can change that if you want. Yeah, so again, this is a really subjective thing. You're going to have to make some judgment calls. You're going to need to define for yourself what these categories are, what they mean. But then you're going to go through and just digitize all the land use categories into some shapefiles. You can kind of do this in a lot of different ways. The lab gives you a suggestion for how to proceed with this, and the tutorials show you a method, but it's pretty much up to you. The digitizing and the mapping is somewhat subjective, but we can quantify the change over time by calculating percent change. I want to show this example really quick because I want to make sure that you aren't going to just calculate the change in percent total over time. So let's say you've got 4 categories. You have your acreage. I calculated it in meters squared. You can calculate the percent total for each year of each land use type. So the riparian area was 3% of the total in 1953, and it was 5% of the total area in 2002. So when I say calculate percent change, I'm not looking for 2%, right? I'm not talking about a 2% increase. I'm talking about an almost 100% increase. It went from over 10,000 meters squared to over 20,000 meters squared. I'm talking about this change, the almost 100% increase in area. And to calculate that, you're just basically comparing new values to old values. So this is a pretty simple way to calculate percent change. You divide the new value by the old value, multiply it by 100 to get a percent, and then subtract 100% to get the change or the difference. When we talk about the new and old values, we're talking about the acreage, not the percentages. So for the riparian area, you would divide the new area by the old area, multiply it by 100, and then subtract 100%, and it equals a 90% increase in area. And that's what we're talking about. This area relative to itself almost doubled in size. So hopefully that helps. A negative value is just a decrease. So agriculture, and this is a really shoddy example, hopefully you'll be more detailed than this in your land use mapping, but agriculture in this example went down from 1953 to 2002, so we see an 88% decrease over time. If you have any questions, let me know. I'm just including one map to show you, one way that you might present this for your final map. And that's it. Any questions, let me know.